Hello everyone, and welcome to this short tutorial video where we will be looking at how we can leverage the HuggingFace platform to actually run large language models locally while leveraging the Inference API that HuggingFace offers. More specifically, we will be looking at how to run Mixtral, which is as stated in HuggingFace blog, a state-of-the-art mixture of experts model that is available on HuggingFace. And the idea is that in HuggingFace, models are hosted in a kind of a repository format. As we can see here, this is the corresponding repository for this model we'll be using today, where all the files are here available for download and running it by yourself if you want. And alternatively, which is what we will be doing today, you can also use their already configured and readily available API to run it yourself. And the idea is that this model is one of the best open source models that is currently available. And we'll see just how easy it is to deploy it while relying on the Hugging Face APIs. And additionally, we'll also see how we can actually package it with Docker so that we can, for example, integrate it in pipelines where we will be running integration tests, where it's super common to have most of the dependencies Dockerized nowadays. And we'll also see how we can actually query the large language model against a running Docker container. So the idea, for those of you who don't really know about Hugging Face, is that they offer a really nice solution here, which is their Inference API here. And the idea is that with this hosted Inference API, all the actual inference computations are offloaded to Hugging Face themselves, and we can test and evaluate for free, hundreds of thousands of models, or even our own private models. Of course, they also mention it here very explicitly that this API is free to use and rate limited, so this is not suitable for production. However, it can be really nice as a way to experiment either locally or even, for example, in pipelines when you are starting to test out some prompts, getting a bit of a feeling of how these models handle input, what's the kind of output format they expect. So all of these aspects can be easily tested against this kind of hosted inference API. We will be looking at this model from Mistral AI, which is currently the leading open source model currently available. There is also quite a lot of useful information about this mixture of experts architecture in their blog. Highly recommend you to read it and go over it to at least understand a bit the architecture behind it and the ideas behind it, which is of course super interesting to do. It's all really really well detailed in here, a lot to learn from. And with let's say this theory part out of the way, we can actually now delve into the code itself. So the idea, like I said, is that we will offload the real computation the inference itself that will run against the model that is hosted somewhere else. In this case, it is hosted on this shared infrastructure that is managed by HuggingFace. And we will offload the actual inference there. The idea is that we will package it around a REST API. In our case, it will be actually a Python FastAPI that will basically support the creation of an endpoint called just chat. That basically it will be a post. It will be a post method, and essentially we will pass a chat request to it, and in this chat request we basically have a message which is essentially our prompt. So what we give to the model as input, we can also configure if we want parameters like the temperature. So this is kind of how creative or not the model will be, the amount of maximum new tokens that will be generated by the model, as well as other things like repetition penalty and so on and so forth. So the idea is that we will just have one single endpoint being exposed by our FastAPI server. And essentially what this will do is that it will then rely on the large language model itself, so on the inference client, of which the server counterpart is actually hosted by HuggingFace, to actually generate some text. So we can see here that we first instantiate the inference client on line 3, and then very easily we just format the prompt according to a specific formatting type. The idea is that each large language model will have its own preferred way of formatting prompts, and it will expect different formats from the for the request body and also for the prompts that the user will send, as well as also having specific limits on the maximum amount of tokens it can generate, the size of the context window, and so on and so forth. So for now, we will simply have the most basic configuration possible. The two important details are these two things, these two parameters. So details is set to false. This means that the output won't have any detailed information about things like penalties and probabilities of the tokens being generated, etc. And we also disabled the streaming mode, which is very common to see in chatbots and agents style of deployments, where the text appears kind of in a stream. But yeah, we have disabled that, and this return full text set to true. This just means that following a more compliant API design fashion, we will just return the entire response all at once. And with these two building blocks combined, we can then assemble a very simple Docker file where we start with the base image, in this case the Python base image. We will copy the working code into our work directory in the image. We will install everything, so our requirements.txt, it's just these three dependencies. So the Hugging Face sub, which is essentially a Python library that acts as a wrapper for the Hugging Face API itself, FastAPI, and UVcorn, which is essentially the API and the server that we need to, let's say, create our own REST API that will be exposed in our Docker image. And then with this in place, we can then build our Docker image. So essentially, we can just do something like Docker build. We can tag it with demo underscore Hugging Face, and we build the current directory. So this will build the Docker image and tag it like this. And then the idea will be that once we run this, we can then start it, and then that will expose the chat endpoint that we just saw via the Fast API, and we can then issue, for example, a post request with curl, and then we will see the output from the model. So let's see. We have already built it, so it built correctly. So let's just grab the tag here, and we can simply go and do docker run. We pass the tag to it, press enter. Okay, it started. This is good. The idea now is that we can just go and do docker ps, and we will now see that it's running. And the idea is that we can now send a curl, a post request with curl, similar to this. Obviously, we need to ensure that there is a specific exposed port here. In this case, we see that we don't have it here, so that's the first thing we need to fix. So the idea is that we can just now pause this, we do docker run, and then we can do dash p80. The idea is that the port where the server is running will be exposed, and then it will be mapped to a specific port in the container. So here we are. Now we can see that the port where the server is running is 80, and it's now exposed through the outside through this port. So this means that now we can do something like this with our post request. You will see that once we switch the that mapped port on top, what will happen is that we will issue the request. The inference client will be called with the model that we chose, and we will get the completion back. So let's just try it out. Now we hit enter. Takes a while the first time, and the idea will be that we will get a response back from the model, and essentially this response was first generated on the HuggingFace servers, and it was just then sent back to us via the client. And as you can see, we then get our carbonara recipe back. It works really well. And yeah, this is how easy it is to actually assemble and package a large language model that is hosted on HuggingFace while relying on their free Inference API. The advantages of this, of course, are several. Is that now with this running image, what we can do is that we can, for example, use it in the ambit of running integration tests where some services are Dockerized. For example, in Java, we could leverage the test containers library. That is a very popular choice to essentially spin up services that are running in Docker containers. So by creating this kind of wrapper package with Docker against an existing and already hosted large language model by Hugging Face, we can leverage it super simply in our own setups. So yeah, as you can imagine, this opens up a whole new world of possibilities for experimenting, trying out new state-of-the-art models, and yeah, exciting times. And I hope you liked this tutorial. And until next time.